Hello everyone. This section is titled Advanced Container Running Techniques. This is an introduction to the section. So, containers can do more than you think. If you do not already know that, a container is an instance of a Docker image. You can use it to run your application, which will be bundled with its own runtime environment, like Java, Python, Node, whatever, and also any kernel libraries that it might need. However, they can do more than just that. So, what are we going to cover in this section? First, we're going to see how you can run a GUI application right from your container. If you thought that containers can only be used for running headless applications, think again. Then, we are going to deal with what's called zombie containers, in which a container thinks that it is running, while actually it is dead. Finally, we're going to have a look at how to run containers on remote platforms like VirtualBox, AWS, Azure, Google, OpenStack, and other platforms using an amazing piece of software that is called Docker Machine. In this video, we are going to learn how to launch a GUI web browser from our container. Most of the time, containers are used to run what's called headless applications. A headless application is the one that does not need or have a graphical user interface for the user to interact with. However, sometimes and for some reasons, you may be forced to run a GUI application, but you want to run it in an isolated environment like a Docker container. Fortunately, there is a way to do this. In this lesson, we are going to see how we can use X11, which is the software or the application that is used on Linux to launch GUI applications. We are going to use it as a shared component between the host and the Docker container to launch a Firefox web browser. So I would just like to note first that this scenario is only going to work on a Linux machine that has the graphical desktop installed. Something like Ubuntu, Fedora, or CentOS is going to work perfectly on it. It's not going to work on OS X or on Windows. So in order to start, I'm going to create a directory for our work. Let's call it my Firefox. Let's start by doing a quick upgrade or update to the repositories. So sudo apt get update, and then I'm going to install some prerequisites for this scenario to work. Namely, it's gonna be xorg, xoth, and open box. Okay. Then I'm going to start editing my Docker file. For this scenario, I can use Ubuntu, the latest version. I'm going to run apt get update, immediately followed by apt-get install the Firefox browser -y in order to avoid any interactive prompts. Then I'm going to add a group for this container. This group is going to hold the group ID of 1000. We're going to see why in a moment. Group name of Ahmed. Then immediately after adding the group, it's going to add a user that is called Ahmed. It's going to give it a home directory of home Ahmed, a shell of /bin/bash. Of course, the name itself is going to be Ahmed, and the UID or the user ID of this user is going to be 1000. The GID or the group ID is going to be also 1000. So using this user for the rest of the container, we are going to declare an environment variable that is called home, and it's going to point to /home/Ahmed. And finally, we are going to run the command that is going to launch this container, which is usr bin Firefox. Okay, so this is my Docker file. All what it does is install Firefox, add a group and a user with a UID and GID of 1000. Why I'm using 1000 is because the current user of this machine, of this host on Ubuntu, is called Ahmed with a user ID of 1000 and a group ID of 1000 and with the name Ahmed. So I'm creating the exact same user inside the container so that when I try to share the socket files between the container and the host, I do not have any permission issues. So now that my Docker container or my Docker file is ready, let's use it to build the Docker image. So docker build-t. Let's call this image my Firefox and give it a target directory of the current directory. All right, and it has built our image successfully. Let's clear the screen. And now we are going to do the command that will do all the magic. Sudo Docker Run -e for the environment variable. We're going to pass in the display environment variable. The current display environment variable is going to be passed or injected inside the container. I'm going to mount $home, which is the home directory of my current user, and specifically the file that is called xauthority. This is the file that is responsible partially for running the GUI applications. It has to be inside the home directory of the user that is running the application. I'm going to mount this same user, this same file, to /home/ahmed/x authority inside the container. So you see what I'm doing here? I am using the exact same file structure, the exact same file permission and file name inside and outside the container so that it is running as if it's running on the host, not inside a container. Finally, we are going to use --net for the network, and we are going to use the host network. If you remember from the first section of this class when we discussed the different types of networks that Docker uses, and we said that the network of type host means that the container is going to make use of all the network resources of the host. It is running as if the host itself is running. So it's going to have access to all the network interfaces, and it is also going to have access to the socket files. And X11 uses a socket file. The socket file is a Unix technology that the daemons or the services that are running inside Linux or Unix use sometimes to communicate with each other. So we said that having a socket file share between the container and the host will enable the container to run GUI applications as if they are running on the host. We're going to see now in a moment what this means. Just give it the name of your image, which is my Firefox, and press enter. And immediately, as you can see, we are launching a Firefox browser. It is giving us the first page that appears whenever you start the Firefox browser for the first time. So as you can see, we are able now to run a GUI application from inside our Docker container. So you might be asking yourself, why would you want to run a GUI inside a container, specifically Firefox? Well, the use cases of this are numerous. For example, a security auditor or a security professional who wants to run a sandboxed version of Firefox, perhaps for testing some security vulnerabilities in the browser, and he or she wants to access some vulnerable sites and examine the strength of the security updates that have been added to the browser, but they don't want to risk their own PC or their own machine, even if they are working with Firefox in the private mode. It is not the safest solution. So a very quick and easy way to do this is just to sandbox the Firefox environment entirely inside a container. So whenever you run Firefox, it's running in its own process inside a container. It has nothing to do with your machine or with your other processes. So instead of running it in a virtual machine, which will take a lot of time and effort and of course a lot of space and resources to get it up and running, a Docker container might be the best approach in a case like this. So I hope by now you've seen how we can easily run a GUI application inside a container just by using some tips and tricks, sharing the ID of the user and the group of the user that is running the Docker container and the host inside the container, and mounting the xauthority file inside the home directory of the user to the home directory of the same user inside the container, and using the network type of host, you can easily enable your container to run GUI applications.